Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our exercise for regression in PVTP software. We are still dealing with compositional oil modeling, and now we have arrived at these lab data weightings for regression. In previous video, we have dealt with saturation pressure, and now let's continue with the constant composition expansion. Okay, so select the constant composition expansion from the lab experiments. Here, the list. Here, the liquid density and viscosity are of particular importance. So let me expand this. Relative volume is important, but it's not that important. Okay, the most important things are oil density, the liquid density, as well as the viscosity. For the relative volume, it is the slope of the curve rather than the absolute values that is of greater importance, since it is directly linked to the fluid compressibility. Okay, any data we are unlikely to use in the regression, such as the relative volume or erroneous data, can be excluded by selecting the relevant data points and then pressing, as I said before, exclude. Additionally, we may wish to exclude some data point in order to speed up the regression. You can do that as well. The process of deciding which data points to exclude can be aided by plotting the entered data as a function of pressure and temperature. So you can plot them to identify outlier or unphysical behavior of those data. This can be achieved by opening the PVT sample and regression objects side by side. So let's do that like this. You open the PVT sample and then you can go to enter lab data. Here we are dealing with constant composition expansion and you can plot lab data. The most important thing is oil density as well as oil viscosity. Okay, so let's set them side by side. And on the right, we are focusing on oil density first. Okay, so it's like this and like that. Again, the data can be plotted in the PVT sample object and the respective data points either included or excluded in the regression object. For example, when plotting the liquid density here, and if we zoom in on the density profile above the bubble point, it can be seen that the curve appears to be slightly kink here, near the bubble point pressure. Okay, here. This data point is best excluded to avoid the equation of state, our model, fine-tuned to reproduce this density profile. So we can exclude this point. Okay, so let's do that. So we will exclude something that looks weird, maybe error and unphysical, but we can also exclude some data just to improve the computation process, to faster, to accelerate the calculation process, to speed up the regression. Okay, so you can exclude the data that looks weird or error or kink, okay, and then unphysical and some good data, but you just want to remove them for speeding up the regression. Okay, so you can follow me. We will exclude all the relative volume for the regression. Okay, exclude. And then let's go to liquid viscosity. Okay, check the oil viscosity first. I'm going to remove the second, third, and fourth while maintaining the 10 high importance. And then the 6 and then the 8, you can press on control button. And then the 10th and then the 12th and then the 14th, okay, of the liquid viscosity. Exclude. Okay, and then every second entry of the oil density, just to improve, to speed up the regression. Exclude. Okay, so let me expand this. So for the strategy, we will maintain the oil density and oil viscosity at high importance, 10, the grade, and we will remove for the regression the relative volume, or maybe not remove, but rather exclude. So we will exclude the relative volume and some data for oil density as well as oil viscosity to speed up the regression. Okay, so I think we can stop it here. In the next video, we will deal with the differential liberation for the weighting for the regression. Okay, until then, thank you.